Hello, people, and welcome to the lab. My name is Red, and today I thought it would be interesting if we decide to take a look into microcontrollers, what they are, what exactly they do, and show off a small little application that I was able to make with limited experience to hopefully give you guys some inspiration and show you that it is okay to start small and make something that might not impress everyone, but still something you can be proud of. So let's jump right in. Microcontrollers can be seen as mini computers in the most basic terms. They are all around us. Microwave, oven, refrigerator, and even some toilets. They can all be controlled by microcontrollers. These mini computers, I say in quotations by the way, control some sort of function that is needed. They allow objects to interact with the world around you. For instance, how does your microwave understand what you want it to do, such as turning on for 30 seconds to reheat some leftovers? If we want to visualize this out, you press 30 start, and that sends a signal to the microcontroller, which using the memory and instructions on the device, it will go through some means and tell the microwave to turn on its interior. So that's cool and all, but why is it worth learning about them? Well, let's think about it. It allows us to have a better understanding of how our current technical world works, and it can give us the ability to create pretty cool stuff. If that sounds in any way interesting, stick around and I'll show you where to get started. Well, let's first look at our options. There are thousands of microcontrollers, and you can even get some made for your exact purpose. Good starter ones include Arduino and Raspberry Pi. They have a myriad of support and starter projects that can get you going. For the remainder of the video, I will be talking about the Raspberry Pi as it is my preferred choice, but the same general concepts can be applied to Arduino and others. Now, if we navigate over to Raspberry Pi's website and click the hardware section, we can see a good amount of products that Raspberry Pi has. The main ones I want to draw your attention to are the Raspberry Pi 5 and the Raspberry Pi Pico. For all intents and purposes, Raspberry 5 is a mini general purpose computer, meaning that it is able to run an operating system, which allows it to be used for some advanced things such as servers and even control some robotic applications. But this also means it can run retro games and even Minecraft. It's small and affordable. It is not classified as a microcontroller. Here we can see the Raspberry Pi Pico, only priced at $5, and this is a real microcontroller right here. One thing you might have noticed is that it says now with added wireless. This means that the Pico can connect to the internet, and we can actually even set it up to control the actual device through the internet. So there is a myriad of tutorials out there that you can get started with these things. So what I thought I would do is to ease the dauntingness of actually getting started is showing you something that I actually expanded upon one of these basic tutorials into. While showcasing, I'll also briefly explain some of the code and how it works and give you an idea of what you can do. Remember, it is always okay to go in and mess around. A lot of the time it won't work, but sometimes it does, and that's just pretty cool. Now, a short disclaimer before we actually get into the brunt of the showcase. With the nature of microcontrollers, you will undoubtedly eventually find yourself exposed to slash working with electrical circuits. Please, once you get to that point, read some safety guidelines for working with electrical circuits. Microcontrollers usually work around the 3.3 voltage range, which is relatively safe, but please do the research and make sure you understand what you are doing and the safety precautions you should take. Now I'm going to start by showing you the setup I have for testing my Pico. Here you can see the device plugged into a breadboard, which is basically just a circuit board to say the least. I have it actually connected to a Raspberry Pi 5 to program it on. This is not at all something you have to do, but it is very seamless. They have built a operating system for the Raspberry Pi 5, which has incorporated my Raspberry Pi Pico integration. So you can set it up really however you like. There's several beginner tutorials out there showing you how to get it set up. But I would highly recommend checking out the Raspberry Pi 5 just to get you started. Now let me show you some of the software I made that utilizes this Pico. So here we can see the base of an application that I have written for the device using MicroPython. MicroPython is a simple but effective way to get started messing around with these things. I actually took a basic tutorial on controlling the Pico W using your local network and developed it into a pawn controller. Here we can see the main function. It's not that bad when we boil it down. I have built a custom timer object which keeps track of when the output should be enabled and disabled, which is initialized on startup. I have also made a custom web page that needs to be loaded into memory for the device to be able to use. After that, we connect the device to the internet, then create a local server that points to a function that handles the client. Now, if you have zero programming knowledge, that can sound like a lot, but if we boil it down, simply all this is doing is getting the device to be in its active state. If we start looking at some of the utility for interacting with the hardware, we can start to actually see how simple it is to interact with the world using these microcontrollers. Under the hardware section in our variable definition, we can see that you actually interact with the pins on the device. So if we look at enabling output, it can be as simple as telling output 1 to turn on. This will lead to some voltage out of the pin and allow us to turn on lights, or even better, turn on other devices that can do something to the environment. Now that you see the basics of the basics, let's look how this broad aspect of just enabling stuff can be applied. This project is meant to control a pond in my backyard. We have to interact with pumps and a water supply and make sure the pond is maintained. So how could we accomplish this using the basic idea that our microcontroller can turn on and off outputs and interact with the internet? I dare you to brainstorm a few ideas right now. I'll wait. Well, there are actually a lot of ways we can accomplish this. The way I decided was to create timers that would be able to be configured via a web page, which are loaded up on the device, turning on, and having these timers be able to activate and deactivate the outputs. That sounds like a lot, but remember, I started from knowing two things that the thing could do: interacting with input and output and connecting to the internet. And then over time, slowly but surely, I flushed out the ideas into what the project turned into. Some of you may be intimidated by this, but it is important to realize that if I saw this when I was starting, I probably would have been intimidated too. But now I know how it works and how I implemented it. And the crazy part is that it could seem impressive to some, but others would look at some of this and find hundreds of ways to improve it. The important part was that I started because of a project I randomly thought of and made something that I think is cool. And so can you. You may not need a pawn controller, but I'm sure there's something that may have crossed your mind that you may be able to use a microcontroller for. If that is the case, I challenge you to start doing some research into this stuff, and I hope you can make something. Go at your own pace and have fun with it. If you are curious to see the code and this project in action, leave a comment down below and I can make a full showcase video with links to the working code. I hope you guys enjoyed this little showcase and that it made you want to look more into our technical world. And always remember, the good is out there. It's only one step away. I'll see you later, folks.